Okay, so let's solve this equation. Now, the method that you will hopefully remember, and the way it works out, worth reviewing, okay? One of the first things we saw first semester, but it's kind of profound. Some really kind of important techniques, but you want to be aware of. Okay, so for this equation, P of t is negative 2t squared. That's actually what we call P tilde of t over here. So let's kind of keep that notation, okay? So P tilde of t is negative 2t squared, so capital P of t is an antiderivative of little p tilde of t, and we'll call it capital P tilde. Okay? And we're just going to use negative 2/3 t cubed. So e to the capital P tilde of t, and to distinguish my capital P from my small p, because I keep writing things in different sizes, I'm going to make it kind of an emphasis by doubling up the stem of the p. Okay? Okay. Just so we're sure we understand what we're saying. Okay? Well, that's e to the negative 2/3 t squared, t cubed. If I multiply both sides of this equation by the integrating factor, the left-hand side becomes the differential, okay, of y(e) to this, okay? So, I'll just say multiply the equation by e to the negative 2/3 t cubed. And we get e to the negative 2/3 t cubed v prime minus 2t squared times e to the negative 2/3 t cubed v equals e to the negative 2/3 t cubed multiplied by negative 2e to the t. And I'm getting optimistic about the solution because I know in advance that I've got to be able to integrate this. Actually, no, we're not going to be able to integrate that. Okay? But that happens. Okay? If that t cubed had been a coefficient out here, we would have been, had a t here, we would have been able to integrate it. But you can't always expect that the function is going to cooperate with the idea that you want to integrate it. Okay? So, anyhow, the left-hand side, and you can check this out, is the derivative of the integrating factor times v. Because if you take the derivative, you're going to get the derivative of this times v, okay? Well, that's what we have here, okay? Actually, it isn't, but we'll figure out why in a minute. No, it is. And then this times the derivative of v, which is this, right? So it's easy to check that out. And this equals negative 2e. Now I can combine the exponents. It's going to be e to the t minus 2/3 t cubed. Okay? Which I don't believe we get any way of integrating. Yeah, it's always possible that there's something I'm not seeing because I'm just looking quickly, and this is kind of off the cuff because it's an answer to your question. So never trust me when I say it can't be done. but it really looks like it can't be done. Okay, so anyhow, e to the negative 2/3 t cubed v equals an integral of negative 2e to the t minus 2/3 t cubed dt. So v equals this integral bunching stuff up here that you know what I'm writing for that integral over e to the negative 2/3. Okay? Now we can't do this integral, but in general you get an integration constant, which of course is the constant you need to fit this to whatever initial conditions or boundary conditions or whatever you have on the equation, right? Okay, so just reminding you of that. But since we can't do the integral, we're not going to illustrate that. Okay? So I'd go back and do some equations. And y equals reciprocal square root of v.
Your t cube still comes down, right?
The what?
Should that be e to the negative 2/3 t cubed?
Oh, yeah.
Okay. I just want to make sure it still comes down.
Yeah, that's your coefficient here. Okay. And I was kind of hung up on the idea, well, that's going to be this times e to the 2/3 t cubed, right? But again, if you can't do that integral, it's not going to help.